In this video I'm going to take a look at 3 examples that deal with those segments that are in circles, dealing with the lengths of those segments. So my first example, I want to calculate the value of x. And what I like to do is I just like to go back to my circle book and I like to find a picture that looks like this and then use the formula that's there. So when I look at this formula, it tells me that essentially I like to go back to my color, and it says, well, if I take the length of the whole secant and I multiply it by the outside part, it's going to then equal the length of the whole other secant, which would be this one, multiplied by the outside part, which will be just right here. So now I can take and I can set up my equation with all that information. So if I look at the red, the whole red piece is going to be 8 plus x long. It's like the whole red. Multiply that by the outside part, which is 8. And then if I take the whole other secant, which is going to be the 10 plus 24, so 34, and multiply that by the outside part, which is 10, I have an equation that I can now solve. Just a matter of going through and doing it. So if I distribute on the left side here, I'm going to have 64 plus 8x, and then my right side is going to equal 340. If I subtract the 64 from both sides, I end up with 8x equal to 276, and then I just have to divide both sides by 8. And after all that's done, I find out that the value of x is equal to 34.5, and in this case it would just be units because I don't have any other label. So I've calculated the length of segment HI, and essentially that's what it asked for when it asked me to find the value of x. Problem 1 done. Now I'm going to go into my next one. So now my next one, I see a couple chords intersecting inside the circle, and I want to calculate the value of x again. Well, this one's a little bit different, because now we just have to look at the parts of each chord. Remember, multiply those together, so I'm going to take the red and the blue and I'm going to multiply them together. And then I'm going to take the green and the purple and multiply those two together. And I'll know that the red and the blue multiplied together is going to equal the green and the purple multiplied together. So I'm going to end up then with 8 times x, and that's going to equal 12 times the 9. And now I have an equation to solve. So what I'm going to do is I'm just going to get my x all by itself right away. Divide both sides by 8. And on this one, I find out that the value of x is 13.5. And again, this would be units because I don't have any other label. So it's a matter of finding that right picture in your circle book, figuring out which formula you need, plug them in, and then you have it. Now my last one, again I'm going to want to find the value of my x, and notice there's a lot more x's this time. And just kind of a little piece of information here, it says the segment that appears to be tangent, assume that it is tangent. So that would be this segment on the bottom that's x plus 4 long. That's my tangent segment. So I look at my circle book and I find a picture that looks something like this, and I'm going to use the formula that's involved there. My circle book tells me that I need to take the length of the whole secant, I need to multiply that by the length of the outside part of that secant, and then I know that's going to equal the length of the tangent segment times the length of the tangent segment. And now I'm going to put my equation together. So now that whole red segment is the x, but it also is the x plus 2, so I'm going to have to add those two together. Well, x plus 2 is 2x plus 2. So there's the length of the red. I have to multiply that by the blue, which is x, and then I know that's going to equal, I look at it as the whole tangent segment, which is x plus 4, multiplied by the outside part of the tangent segment, which is the same thing because the whole tangent segment is outside. And now I have an equation to go ahead and solve. Well, this one's going to get a little messier, but it's something we can still do. So if I distribute here, I'm going to end up with 2x squared plus 2x equal to, and then on this side I'm going to have to FOIL. First, x squared, my outsides, 4x, my insides, 4x, and my last 16. Now I look at this and I have x squareds in this equation, so I have a quadratic equation. And one way to solve a quadratic equation is to get one side equal to 0. What I'm going to do to get my one side equal to 0 is I'm going to get my right side equal to 0, which means I'm going to have to subtract an x squared. I'm going to have to subtract the 8x. I'm going to have to subtract the 16. Do the same thing over here. Subtract the x squared, the 8x, and the 16. And now I'm going to be left with x squared minus 6x minus 16 equal to 0. And then what I'm going to do to solve my quadratic equation is I'm going to try to factor it, make my double set of parentheses, still equal to 0. And being x squared is the first term, I know that that's going to be an x and an x in each set of parentheses. And now remember, the numbers that go in the second part of each parentheses have to multiply to be the negative 16, but they have to add together to be to the negative 6. So I have to think about factors of negative 16 that are going to add up to be negative 6. Well, being I have a negative 16, I know one of these has to be negative, one of them has to be positive. And being it's a negative 6 for the blue part that I've circled, I know that my, call it larger number, is going to have to be the negative. Well, 8 and 2 are going to multiply to be negative 16. That's one way, and if I take negative 8 and add 2 to it, I get that negative 6. Now you could FOIL it back together to check it, and if you FOIL it back together, you'd end up right back here. Now once I have those two factors, I notice that it says it's equal to 0. Well, if I multiply two numbers together and my answer is 0, that tells me one of them has to be 0. So I'm going to look at the first one and say the x minus 8 is the 0, and in the second one, say the x minus 2 is the 0. One of them has to work. Now in this one, if I add 8 to both sides, I end up with x equal to 8. In this one, if I add 2 to both sides, or excuse, that was supposed to be an x plus 2, so I'd subtract 2 from both sides and get x equal to negative 2. Now I come up here and think, well, do they both make sense to this problem? Well, positive 8, if I put 8 in for x, the blue is going to be 8 long, kind of that inside the chord of the circle is going to be the 8 plus 2, that's 10, that makes sense, and then the x plus 4 would be 12. All works out. But now if x is negative 2, this blue segment here, that's going to be a negative length, and that doesn't make any sense. Therefore, I know I can rule this one out, and then my x equal to 8 would be my final answer for the value of x. And that's going to conclude my lesson or my examples on special segments in circles.